Welcome to all. In this video, we are going to cover the concept of maximum mode of 8086 timing diagram. First, we will see for the read operation. After that, we will go for the write operation. Actually, in 8086, in order to execute one instruction, we require 4 clock cycles. That's why we have taken 4 T1, T2, T3 and T4. But we introduced the wait state in between the T3 and T4. Means actual data transfer is going to take place in between T3 and T4. So there might be a speed mismatch in between these two states. So in order to avoid that speed mismatch, we need to place the wait state in between the T3 and T4. And next we will start with the ALE, that is address latch enable. So as usual, address latch enable is 1 during the T1. Remaining all clock cycles it is 0. Okay, during T1 only it is high, remaining all clock cycles it is 0. Next, coming to the address slash data. Whenever there is slash between address and data, these are the multiplexer lines, means one pin is performing the multiple operations. So here during same ALE and address both are same. During ALE 1, the address is going to activate. Address lines are activated. During ALE is 0, the address lines also 0. ALE and address both are same. During ALE 1, address 1, ALE 0, address 0. And next, coming to the data. If you see the data here, already here address is active, so therefore here data is low. Okay, and here address is low. In these clock cycles, the data is going to be high. Okay, so here if you see the address lines, we are having 20 address lines in 8086 and 16 data lines in 8086. So from A0 to A15 it is going to cover here, and data lines D0 to D15. Okay, and next coming to another multiplexer line, that is address slash status. Same, during ALE 1 the address is high, during ALE 0 the address is 0. Okay, coming to status, as here the address is high, the status will be low. Here the address is low, the status is obviously high. The status is obviously high. So the remaining address lines comes here, A16 to A19, and the status lines S3 to S7 comes here. Okay, and next we will draw for the remaining status lines, that is S2 to S0 bar. Bar is there, so bar is there means these are active low signals. So for the first two clock cycles, these are active, means active low, we need to draw the 0 here. The first, during T1 and T2 these are active, and next clock cycles these are inactive. So this is about to S2 to S0 bar. Okay, as it is of low signal, we need to draw 0, then only it is active. So if we place 1, these are inactive. And next coming to the DEN. If you observe, in the minimum mode it is DEN bar, but in maximum it is DEN. If you see in the block diagram of bus controller, DEN is active high signal. So during T2 to T4 it is high. If data is enabled, then only we can transmit the data. Okay, during T2 to T4 the data is going to be high. Next, here we are drawing for the read operation. So consider the read signal, that is MRD means memory read bar. Bar means it is active low signal. So whenever data is enabled from T2 onwards, this is also active low signal. As it is active low signal, we need to draw 0, then only it is active. Okay, and next DT by R bar, data transmit and receive. Receive means read operation. We need to while drawing for the read operation, we need to consider only the read bar. So DT by R bar means for read operation it should be low. Okay, this is the timing diagram for the read operation. Now just by changing last two waveforms, then it will become the write operation. Okay, now we will see for the write operation. Just I am changing here the heading write, and here write operation means the two signals will be the memory write bar and one more is DT by R bar. Here memory write bar, it is also active low. Why? Because here in write operation there will be a write only. We are not having any read operation, so just we change it memory read to the memory write. It is also active low signal now, it is the same. Okay, we need not to change. And next here dt by r bar, for write operation we need to consider the transmit, so it is active high, so we need to draw it, we need to change it, just we need to change this waveform. So it is active high, therefore we need to draw the active high for the all the clock cycles, then only it is active. So this is about the write operation. So I hope you all of you understand. Thank you, thanks for watching.